So far, you have done three trig ratios that are sine theta, cos theta, and tan theta. Sine theta was a ratio of opposite over hypotenuse. Cos theta is a ratio of adjacent over hypotenuse, and tangent theta was a ratio of opposite over adjacent. Now, in P3, we are going to study three more trig ratios that are known as reciprocal trig ratios. So the three reciprocal trig ratios are cosecant theta, secant theta, and cotangent theta. These are the names, and these are the short forms. Cosecant theta is written as cosec theta. Secant theta is read and written as sec theta. Cotangent theta is written and read as cot theta. Okay. Cosecant theta is a reciprocal of sine theta. Secant theta is a reciprocal of cos theta, and cot theta is a reciprocal of tan theta. So, do you remember tan theta was the ratio of sine theta upon cos theta? So,
Yeah.
cot theta would be the ratio of, how
Cos
can I
theta
express
over
cot
sine.
theta in terms of sine and cos?
Cos theta over sine theta.
Yes, this is going to be cos theta over sine theta, right? Now, we did some identities. You might have done some identities in P1. Now we are going to look at some identities of these reciprocal trig ratios. So for that, let us consider a right angle triangle. If this is the angle theta, this is x, this is y, and this is r. If I apply Pythagoras theorem, would you agree that x square plus y square is going to be equal to r square?
Yes.
What is sine theta going to be equal to?
Y over R.
Y over r. Cos theta,
X over R.
x over r, and tan theta would be equal to
Y over X.
y over x. So cosec theta would be equal to,
R over Y.
yes, secant theta is going to be equal to r upon x, and similarly cot theta is going to be equal to x upon y. Now, using this, let us divide both sides of the equation by x square. Divide both sides by x square. So if I divide both sides by x square, this is what I get, 1 plus y upon x the whole thing square equals to r upon x the whole thing square. So what is y upon x equals to? What is y upon x equals to from here? Which trigonometric ratio?
Um, Tan theta.
Tan theta. So tan square theta हो जाएगा ये, and r upon x is equal to
Sec theta.
secant square theta. This is one of the identity that will be helpful for us to solve further questions. So you need to remember this identity. 1 plus tan square theta is equal to secant square theta. The other identity is derived in a similar way, but instead of dividing x square plus y square equals to r square by x square, we are going to divide it by y square. Divide both sides by y square. So if you divide both sides by y square, you are going to get x upon y the whole thing square plus 1 equals to r upon y the whole thing square. So what is x upon y?
Um, cot theta, so
Cot
cot
square
square
theta plus 1, and r upon y is going to be
cosec.
cosec square theta. This is another identity that we are going to make use of. And the identity from P1, that was sine square theta plus cos square theta equals to 1, that identity is universal. You are going to use in P3 as well. These are the two new identities that are going to be helpful. Now, if you want to note down anything, you can.
Oh yeah, so please just give me 1 minute to put it down.
Sorry, what?
Can I just have 1 minute to note it down?
Yeah, please take your time. No worries.
So I have it down before.
Okay. The next thing we are going to look at is the graphs of the reciprocal function. So let's just start with the graph of sine theta and its reciprocal function cosec theta. Okay, I'm going to draw first the graph of sine theta. So sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is minus 1, and sine of 360 is 0, right? This is one wave of the sine. Is that correct?
Yes, sir.
And if you extend it to minus 360, the graph is going to be like, like this. It's a periodic function. It repeats after every cycle. So this is the graph of y equals to sine theta. Now I want to draw the graph of cosec theta, which is the reciprocal of sine theta. First thing first, you're going to see where the graph is becoming zero. The graph is becoming zero at 0 degrees, 180, 360, minus 180 and minus 360 over here. अच्छा, so if I know k cosec theta is the reciprocal of sine theta, so what will happen to my function of cosec theta where the value of sine theta is going to be 0? If this value is going to be 0, the value of sine theta is going to be 0, then 1 upon 0 is going to be, see, the sine theta function is 0 at 0 degree, 180 degree, 360 degree, right? So the
Yes.
value of sine theta is 0, and cosec theta is the reciprocal of sine theta, which is equal to 1 upon sine theta. So if the value of sine theta is going to be 0, then the fraction will become 1 upon 0. And 1 upon 0 is,
1.
no, 1 upon 0. 1 upon 0 is not defined. There is
Okay.
no, it is going to have a discontinuous function. 1 upon 0 is undefined. So what we are going to do is we are going to make a vertical line known as the asymptote at 0 degree. So I'm making a red line over here indicating that the function will not pass through this line. Now the same thing is going to happen when sine theta was 0 at 180 as well. So there is going to be a vertical asymptote line over here at 360 as well,
Minus 180.
minus 180 and minus 360. Okay. Then, when the value of sine theta was 1, what is going to be the value of cosec theta?
1.
Yes, this is 1, this is negative 1. When the value of sine theta was 1, then cosec theta is also 1 upon 1, which is 1. When the value of sine theta was minus 1, 1 upon minus 1 is going to result at minus 1. So at 190 degree, the value was 1. Here it is. At 270, the value was minus 1. So the value of cosec theta is also becoming minus 1. But now see that this part. The value of sine theta, from this point, the value of sine theta is decreasing. And sine theta is in the denominator. So if the value of sine theta is decreasing, what is happening to the value of cosec theta?
Increasing.
Increasing. So the graph is going to turn like this. It is going to increase. When the value of sine theta is decreasing, then the value of cosec theta is going to increase. Similarly, when the value of Sine over here from this point, when the value of sine theta was increasing to from the left, this is going to decrease, and same is going to happen over here. Okay, is this making sense?
Yes,
This is the shape of cosec theta. Now I want you to complete this on the left hand side of the graph as well. I'll just be back. I'll have to attend a call. I'll just be back. All right. Did you complete this?
yes, you make the same things, right?
You make the same thing, but you always see the graph on the left for the sine. The minimum, this value is coming at minus 1 at 90 degree, and then the shape is going to go like this, and from 270 it is going to go up like this. Is this the same shape that you get?
Yes.
Okay. These red lines are known as vertical asymptotes, and you can see the gap between the, so in the cosec curve, the y equals to cosec theta curve, the the asymptote starts from 0, and then there is a constant difference of 180 degree or pi degrees between the asymptotes. 180 degree का difference है और pi radian. 180 degree or pi radian. That is the difference. And the minimum value is 1. See, if we look at this graph is, the value of the graph is going down and down, and the minimum value is 1, and then the graph increases again. And if you look at the bottom part, the value is increasing, 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 and the maximum value is -1, and then the graph has a fall again. So we are going to say that the minimum value is at 1 and the maximum value is at -1. The period of this graph is also, so this graph together with this part makes one cycle of cosec theta. So the period is 360. Period is 360 degree or 2 pi radian. You might be asked to draw it in radians as well. Always deal with the asymptotes first. In the graph of cosec theta, the asymptotes are 180-degree apart or pi radian apart. So, so asymptotes are 180-degree or pi radian apart. Is this okay?
Yes, sir.
All right. First of all, I'm going to do the basics of all the graph of cosec theta, sec theta, and cot theta, and then we can look at into the variations of these graphs. So, is there anything that you would like to copy down, or should I move on?
So you can move on.
Oh. Now, the next thing that we are going to see is the graph of y equal to cos theta and its reciprocal function y equals to sec theta. Okay, let's recall how does a graph of cos theta look like. This is 1, this is -1. The graph of cos theta starts from 1, goes to 0 at 90 degree, goes to -1 at 180 degree, then comes up having 0 at 270 degree, and at 360 it is going to be 1. So this is one of the cycle. This is one of the cycle of cos theta. If I extend the graph to the -360 degree, it is going to look like this, right?
Yes.
So the period is 360 degree. And then we are going to look at the graph of sec theta, which is the reciprocal of cos theta. So first of all, we are going to see where is a graph becoming 0. The graph is becoming 0. The graph of cos theta is becoming 0 at 90 degree, 270, -90, and -270. So in the graph of secant theta, these points are going to be my asymptotes, because 1 upon 0 is going to be undefined. So if cos theta is 0 at 90 degree, then 1 upon 0 is going to be undefined at 90 degree. So I'm going to make a vertical asymptote on 90 degree, then at 270 degree, then at -90 degree, then at -270 degree. Okay.
Yeah.
Then cos theta was 1 at an angle of 0. So if the value of cos theta is 1, then 1 upon 1 is
0.
1. 1 upon
Yeah.
1 is 1. So at 0 degree, this is going to be 1. Similarly, at 180 degree, it is going to be minus 1. Now, what is happening to the cos theta function after this point? It is
Decreasing.
decreasing or increasing?
Decreasing.
So so secant theta is gonna increase. Same goes till here. Over here it is minus 1. It is increasing. So in secant theta, it is going to decrease. Then at 360, it was 1. Before 360, it's decreasing. So it's going to increase. At minus 180, it was minus 1. So we will have a shape like this. And at minus 360, it is going to increase like this. In cosec theta, the asymptotes were starting from 0, and then the next asymptote was at a 180 degree apart distance, that is 180 or pi radian, and the distance between, or the angle between the two asymptotes was 180 degree apart. यहाँ पे क्या है? The first asymptote is at minus 90 and the next asymptote is at 90 degree. And there is one half a cycle of secant theta over here. And these asymptotes are still 180 degree apart. The period still remains the same. Now I can say 180 degree or pi radian. If the question says that the angle is in radians, so all these values are going to be converted into radians. 90 is going to be pi upon 2, 180 is going to be pi, 270 is going to be 3 pi upon 2, 360 is going to be 2 pi. Okay. So I can say that the minimum value occurs at 1 and minimum value is 1 and maximum value is minus 1 for secant theta. The period is still, the period of secant theta is still 360 degree or 2 pi radian, and the asymptotes start from minus 90, and then you can add 180 degree to get the next asymptote. Basically, or you can write asymptotes are odd integer multiples of pi by 2 radians. Odd integer multiples of pi by 2 radians are vertical asymptotes. Okay, you can note this down.
I have an answer.
Are you done?
Yes.
Any questions still here?
No.
Then the last basic sketch is the graph of y equals to tan theta and y equals to cot theta. It's reciprocal. Acha. If you recall the graph of tan theta, you would recall that tan theta already has a asymptote because tan 90 is undefined. Okay, and tan of minus 90 is also undefined. Then the next asymptote is drawn at 270 degree and minus 270 degree. This is just the graph of basic tan theta, and the shape comes like this. You have done this in P1. This is the sketch for tan theta, right?
Yes, sir.
Now we are going to reciprocate it and draw the graph of y equals to cot theta. Y equals to cot theta is the reciprocal of tan theta. So the points where tan theta is becoming 0 will give us the asymptote position. So this line is going to be the asymptote at 0 degree, at 180 degree, and at 360 degree. Then at minus 180 and minus 360. And where the function was undefined, what is 1 upon undefined?
Uh, 0.
It's 0. So where my function of tan theta was undefined, now it is going to be 0. And the shape is going to flip. Wherever it was decreasing, it is going to increase as well. So over here, it is going to be 0. Before 90, as you can see, it was increasing like this. So now it is going to be decreasing, and the shape is going to look like this. Then you are going to repeat the same pattern over here. Is the idea clear?
Yes.
Any difficulty so far?
No.
Okay. Now, in the graph of cot theta, the period is 180 degree. One cycle of 10 gets completed in 180 degree. The distance between the asymptotes is also 180 or pi radian. There is no minimum or maximum value, and you will always get asymptotes on integer multiples of pi radian. So integer multiples of pi radians means that 0 pi, 1 pi, 2 pi, these are the positions for the vertical asymptotes. All right. यहाँ तक बिल्कुल क्लियर है आपको?
Yes, sir.
Okay. Now let's look at some variations. if you get the variations for any one graph, you can do it for the rest as well. So if the question says sketch y equals to cosec 2 theta, you have seen the graph of cosec theta, but now we want to sketch the graph of cosec 2 theta. So there are going to be two cycles of cosec theta within the same period of 360 degree. This is one cycle. Now, since I have the equation as cosec 2 theta, the graph within this distance, there needs to be two cycles. This is one cycle. There needs to be two cycles fit in. Whenever you are dealing with the reciprocal functions, you will always adjust the asymptotes first. In cosec theta, the first asymptote is at 0 degree and the next asymptote is at 180 degree. So the gap between the two asymptotes is 180. However, in cosec 2 theta, the gap between the asymptote is going to be 9. Previously it was 180. Now you are going to divide it by 2 and you are going to get 90 degree. Let's draw this from 0 to 360 only. Previously the asymptotes was as 0 and 180 degree. Now the gap between the asymptote is going to shrink and the gap is going to be 90 degree. So the next asymptote is going to be after 90 degree, then further after 90 degree, then further after 90 degree. So this is 45, this is 135, 225, 315. So the cycle is also going to shrink. The pattern is going to repeat itself. So now you can see that there is one cycle being completed in 180 degree, right?
Yes, sir.
And the other cycle being completed in 360 degree. Is there anything that you want me to repeat? If you are not getting it or if you have any questions, please let me know.
No, sir, I understood this.
Do you consider this to be difficult?
No.
Okay. If this was cosec half theta, then what would be the difference?
Um, then the gap would be small, bigger.
Even bigger, yes. So then the gap, previously you always deal with the asymptotes first. In the basic graph of cosec theta, the asymptotes were 180 degree apart, and the first asymptotes was at 0. The next asymptote was at 180 degree. When we did cosec 2 theta, the asymptotes shrinked, and because we divided the distance between the asymptote by that number, by the coefficient of the angle 2, and we had the new gap between the asymptotes. Now we are going to divide 180 by half and we are going to get 360 degree. That means that the difference in the asymptotes is going to be 360. So the first asymptote is always at 0. Okay. This is 90, 180, 270, 360. The first asymptote is at 0 and the next asymptote is going to be at 360 degree apart. And there is only half a cycle within 360 degree. So at 180, the value is going to be positive 1. And then the graph is going to go up like this. ठीक है? Okay. The same thing is going to happen when you have a function of secant 2 theta and secant half theta. Let us look at an example of secant 2 theta. Are you done till here?
Yes.
Secant 2 theta. So if you remember that secant theta sketch has an asymptote at minus 90 and 90 and the gap was 180, right? Now when you have secant 2 theta, the the distance between the asymptote is going to shrink, and now the gap is going to be 180 upon 2, that is 90 degree. So if the basic secant theta graph had an asymptote at minus 90 and 90 to maintain a distance of 180 degree, then to have a distance of 90, to have a gap of 90 degree between the asymptotes, where should the two asymptotes be positioned?
Sorry, sir, could you repeat that?
Yes, I was saying that in the basic secant theta graph, the asymptotes were positioned at minus 90 and 90 to maintain a gap of 180 degree, right?
Yes.
Now, if we have a function of secant 2 theta, the gap is going to be 180 upon 2, 90 degree. So in order to maintain a gap of 90 degree, where should this and this
Oh,
asymptotes go?
45 and minus 45?
Yes, it is going to move at to minus 45 and 45 to maintain a gap of 90 degree. Then the next asymptote is going to be 90 degree after 45, that is 135. Just a second, I need to answer the doorbell. All right, I'm back. So the next asymptote, would you agree that it is going to be made at 135?
Yeah.
Yeah. Then if I add further 90 degree, the next asymptote is going to be made at 225. You just add 90, keep on adding 90. And then the next asymptote is going to be at 315. Okay. Now, if the question says just draw for the domain of 0 to 360 degree, so I know that cosec the function looks like this. It is going to start from 1. It should have been drawn like this, but I'll only draw this side because I want it to be greater than 0. I want it to be drawn for greater than 0. Then the middle value of 45 and 135 is 90. So at 90, I'll have a center point, and then the graph is going to be an inverted U shape over here. Then 135 and 225 key average value is going to be 180. So the graph is going to go like this. Okay. And 225 and 315 key average value is going to be 270. This is 217. This is going to be completed. But ये वाला part यहाँ पे आके somewhere यहाँ पे रुक जाएगा because we would just want to draw it till 360 degree. Is it okay?
Yes.
Now let's do some questions in radians. The interval is given from 0 to 2 pi radian. I want you to draw y equals to 1 plus secant x. First have an idea of secant x and then shift the entire graph 1 unit upward. So do you want to try this on your own first?
Okay. Yes, I did what I could. I don't think I got it right though.
Okay, you can confirm your answer with mine. Speaking of secant graph, the first thing that I'm going to look at is the position of the asymptote. Now in secant graph, the first asymptote was always at minus 90 and 90. And then, since this is in radians, so I'm going to write pi by 2 over here. And the next asymptote is going to be pi radian after pi by 2. So pi by 2 plus pi, the next is going to be at 3 pi by 2. Okay. And then the next asymptote is going to be at 5 pi by 2. Okay. So I don't want this minus 90 wala part because it starts from 0. Acha, if I just focus on this secant graph, I know that the graph is going to start like this from 1. Okay, let me call this as 1, this as minus 1. Okay, this is 1. You can do it directly, but I'm just showing you the steps. And 2 pi is going to be before 5 pi by 2. Just a second. This is going to be 2 pi. Okay. Now, this is the graph of secant theta. Now, I want it to shift 1 unit up. So, what I'm going to do is I'm going to translate this graph 1 unit up. So, it is going to start from 2, go up like this. This was at minus 1. It is going to go at 0 and come like this. And it is going to go up. Are you getting a similar graph?
Yes.
Good. Now, let's discuss one more important transformation. Y equals to secant x plus pi by 2. Now, if there is a addition or subtraction in the angle, then that is responsible for the horizontal shift of the graph, horizontal shift of the entire graph. Now, if there is a plus sign over here, it will move. If there's a plus sign, then the graph is going to be shifted. Graph goes left. And if there is a minus sign, the graph goes right. You need to remember this. Again, we are going to deal with the asymptotes first. Okay. If you recall the graph, in the graph of secant theta, the asymptotes were at minus 90 and 90. The graph was at minus 90 and 90. 90, 180, 270, 360, minus 90, minus 180, minus 270, and minus 360, let's say. So, in secant, the graph, the asymptote was at minus 90 and 90, which is minus pi by 2 and pi by 2. But now the graph is going to go pi by 2 units backward. Okay, the graph is going to go pi by 2 units backward. So first of all, we are going to deal with the asymptotes. For asymptotes, क्या होगा यहाँ पे? Pi by 2 units left चले जाएगा ग्राफ. So पहले अगर मेरा asymptotes माइनस पाई बाई टू पे था, ये वाला जो asymptote माइनस पाई बाई टू पे था, वो कहाँ चले जाएगा? If the asymptote was at minus pi by 2, it is going to go pi by 2 units backward. I want to shift the entire graph 90-degree backward. Achha, will there be any difference? Hello?
Hello, sir.
Yeah, are you able to hear me?
Yes, sir.
So मैं ये पूछ रहा था कि अगर मेरे ग्राफ में pi by 2 का डिफरेंस आ रहा है and the graph is going to be shifted pi by 2 units leftward, पीछे चले जाएगा पूरा ग्राफ. So is there any noticeable change? Let's deal with the asymptotes first. अगर मेरा asymptote minus pi by 2 पे था, तो pi by 2 units पीछे जाने के बाद ये वाला asymptote कहाँ चले जाएगा?
Pi by 2 units to the left.
So one of the asymptote is lying at minus pi by 2, and I want to take it further away minus pi by 2. Would you agree that this asymptote is going to go at minus pi?
Yeah.
And the asymptote that was at pi by 2, where will that move?
0.
0. Very good. Right. Now, this is when you have dealt with the first asymptotes, you know that there isn't any change in the period. It's just a horizontal transformation. So this distance is always going to be pi. So where is the next asymptote after 0 be made? It is going to be made at positive pi to maintain the gap of pi. Then it is going to be made at 2 pi. Okay. Now, between the asymptotes, I need to complete my graph. So it's going to go like this. Is the idea clear? I have basically shifted my graph 90-degree to the left. Because of x plus pi by 2, the graph shifted 90-degree to the left. If you want, take some time to absorb this concept. Let me know if you want me to repeat anything.
Oh, no, so I got it. It just shifted 90 degrees to the left.
Yeah, and if this was minus pi by 2, then the entire graph would have been shifted 90-degree towards the right. So the asymptotes would have been at 0 and pi again. Okay?
Okay.
Alright, so that's all for today. Please do revise these graphs.
Okay.
In the next class, I'm going to do some more graphs, and then we are going to see how to use trig equation identities. Okay?
Okay. Thank you.
You're welcome.
Office.
Love it.